Hello, welcome to Team F's final presentation for SER 315. Our project is called the Game of Entrepreneurship, which is a cross between the 7 stages of entrepreneurship and the game of life. The team members consist of Josh Lyons, Nam Nguyen, John Olin, and Greg Schoberth. The items on the agenda for this presentation include the prototype demo, the prototypes that were produced for the project, feedback on the prototypes, and how the architectural prototype helped clarify our system design. Also on the agenda are the processes used during the project, where the project stands currently, the risks involved in the project, and how we see the project continuing in the future. To begin the presentation, let's take a look at our current working prototype. The scenario demonstrated is a creation of a new game, the first couple of spins, and how the action or milestone cards are handled. The architecture for the prototype was built using JavaFX with our UML classes and use case scenarios as guidelines. While we focused on writing understandable code, we knew that it was basically throwaway code created for the demonstration purposes. The first screen the user is presented with upon starting the game is the main menu. Here, the user can choose from starting a new game, resuming a previous one, or exiting the game. Upon selecting the New Game button, the user is presented with the New Game screen. Here, the user can enter their starting cash, which is basically the amount of money they have going into their new business. The user can then select from 3 business choices. For this demonstration, the software startup option is the only one available. To start the new business, the user selects the Software Startup button. The user is then shown the main window, which displays the game board, the character pawn, the spinner, and the user's income and net worth. You can see the main toolbar at the top of the screen, which allows the user to start a new game, resume a game, save the current game, and exit. The help menu has an About option which tells the user about the game. To start the game process, the user must click on the Spin button to determine how many tiles the character moves. For this prototype, the spinner works by running through a loop 50 times, and each time a random number is generated from 1 to 5. The game then waits for 5 milliseconds times the loop iteration. This simulates the spinner starting fast, then slowing down, and settling on a number. Once the spinner stops, the character is moved that many number of spaces. An action card is drawn if the character lands on a normal tile, and a milestone card is drawn if the character lands on a milestone tile. The computer then handles the benefits or penalties of the card, and the next turn begins. This process is repeated until the user reaches retirement. For the full game, there will be many different action and milestone cards that will either help or hinder the user, the goal being able to retire with the most amount of money. During the project, we had 4 iterations of the user interface and 2 iterations of the architecture. The first user interface prototype was a hand-drawn sketch. The second was a pencil sketch that basically copied the hand-drawn sketch into the pencil software with a few changes based on feedback. The third iteration was a clickable pencil prototype to see how the flow of the menus and game would go. The fourth and final iteration for this project was the Java prototype that was just demonstrated. For the architecture prototypes, we only had 2. The first was a series of UML diagrams to flesh out the classes and to see how the sequence of events would go. The second and final iteration for the projects was also the Java prototype just demonstrated. We received feedback from iteration 3 of our interface design that drove iterations 4 of the user interface and 2 of the architecture design. Prior to iteration 4, the menu button was off to the right of the game board next to the social interaction area. This made the main menu hard to find. To stick with the user interface standards, we moved the menu into a menu toolbar at the top of the game board. Another change was instead of a continuous loop based off the stages of entrepreneurship, we just added one single game loop with all the stages displayed. We then added action cards to move the player forward or backward on the board to add depth to the game. Also, because we removed the social interactions and multiplayer functions from the game, we redesigned the board to remove those sections. The architectural prototype helped clarify our system design. The three main ways were structure, object consolidation, and project time considerations. By designing the classes and flow of the system in UML, we were able to see where changes were needed in the interface design. We noticed that we did not have enough time to incorporate the scoreboards or the social interactions. Also, we were able to see where we could consolidate like functions into a single class. This saved time and confusion.
Now we come to our process as a group. As Josh mentioned previously, we had 4 iterations of UI prototypes, including a hand sketch, a basic pencil prototype, a pencil click-through prototype, and a working Java prototype. Then we had 2 iterations of architecture, including our UML diagrams and the working Java prototype. I will explain what we learned from each iteration on the next slide. Our group did converge on a solution design, which was shown with our working Java prototype. When we are implementing, there's a strong chance there will be some design changes, but ideally there will not be many if we did our design process correctly. The UI and the architecture integration worked well together. Our initial prototypes were well thought out, and our transition was seamless to our UML diagrams and working Java prototype. There were several techniques that helped us along the way. One technique that was key was personas and scenarios. We learned that these 2 techniques complement each other, and they were extremely helpful in determining who we are building the game for and what is needed in the design. Questionnaire survey was helpful as well for gaining user feedback. As you see below, it's assisted with conforming to EDP and UCD because we would never want to create a complete design without feedback along the way. Both hand sketch and pencil prototyping were helpful as well. One type of technique that was not as helpful to us was the observation technique. To be fair, I do think that this technique can be quite advantageous if we had more time to go out and observe, but for the purposes of the limited schedule in this class, this was not useful for us. Here we see a screenshot of our 4 UI iterations. We learned that the initial hand sketch prototype was essential. We did this because it is the only form of prototyping where we could have 0 restrictions and put on paper exactly what we were thinking in a short amount of time. Some of our group were not familiar with the Game of Life board game, so being able to draw out what I was envisioning for the game was very helpful here. This set the stage for iteration 2, the initial pencil prototype. We were learning more and more about what this program could look like now that we added our design to a professional tool. Then came iteration 3 with our click-through pencil prototype. Here we learned how to fit each page together, and with user feedback, changes to the board layout. Finally, we were able to see our game in action with iteration 4 using JavaFX. For our architecture iterations, we created 4 UML diagrams to help us with the working Java prototype. This activity diagram was helpful in determining the actions taking place throughout the game. This included things such as selecting the game type and spinning the wheel during the turn. The state chart diagram was not as useful in my opinion when we already had the activity diagram. Having states here such as waiting to spin seemed redundant. The sequence diagram was done by an example scenario throughout the game, with actions such as purchase a business or lose market share. Finally, the class diagram was helpful for turning these into methods to implement the code. Our group stayed on schedule with the pace of the class with no interruptions. We worked each week on the techniques in parallel with the weekly assignments, which worked out well in the long run. One risk that we had to deal with was meeting times. Since this is an online class and some of us live in different states and have different work schedules, meeting times were difficult. But our group stayed active on our Google Hangouts chat and we were always on the same page. Another risk we had was overcomplicating the project. We found this to be the case a few times and had to limit functionality to something that we could do within the scope of the class. If we had more time with this project, we would focus on extra features such as a scoreboard, social interaction with multiplayer capability, as well as a cleaner layout of the game board. Our team really enjoyed this project and learning about all the aspects of the design process. For me personally, it was cool to see the parallels from the company I work at. We create video games, and it was cool to see that many of the techniques actually translate to things we do every day. Finally, our team worked well together and there were no issues, except that one of our group mates dropped out of the class, but we were able to pick up his slack. Thank you to everyone for watching.